D-marble is a very old foe, one in which I tackled in my very first video ever. Imagine that, a guy with 0 subscribers trying to tell you that you are wrong. Well, guess what, D? Now I'm a guy with 290,000 subscribers and I'm here still telling you that you're wrong. Not that the amount of subscribers matters, you were still wrong both times. Hello all and welcome along to another episode of Tinfoil Tuesday with me, Simon Dan. Thank you very much for joining me. Yes, D-marble is back today with some interesting points about the moon missions. He seems to think that the Apollo 11 Earthrise picture is some sort of red flag. He thinks that it is a glaring error when it comes to the moon landings and will go on to mention that he thinks they didn't even happen because of this. Does he have a point? Or is he misunderstanding everything again? I'll give you a clue. It's the second one. Let's join D as he starts his presentation.
What's up, folks? It's D and I'm back with another presentation. Very briefly, let's talk about why the Apollo 11 Earthrise picture is a huge red flag. Now, what I like to do is build my case in components. So the first component is going to be the moon.
Oh, he's going to build his case. I see. Come on then, D, build away.
So we're just going to look at this video real quick from one of the most recent full moons. That was the one from back in December. I got this video December 12th, I believe it was. So about the moon, they tell us that it's 239,000 miles away or so.
Yes, correct.
That the moon is 4 times smaller than the planet Earth, according to the heliocentric model.
Otherwise known as reality, yes?
But one thing that I find odd about the moon is that you can zoom in and get so much detail using a Nikon P900 or P1000. Mine's a Nikon P900, and that's how I was able to get in and capture this much detail looking at the moon where it's supposed to be 238,000 miles away. I find that to be a little odd.
Why? The moon has a diameter of 3,472 kilometres. That is positively huge. It would be like having the entire country of the United States in the sky. I'm sure you'll be able to zoom in on that and pick out some detail as well.
Because, I mean, now if you go back and look at some of my older videos, when I first got started with this flat earth stuff, I did one video where I drove out to an intersection. I recorded a trip meter down to the end of the road. I recorded a tree line. Now I zoomed in on that tree line. That tree line was only like 2.5 miles away. I zoomed in on it, and there was so much atmospheric distortion to a point to where I couldn't get as much detail.
Two things here. You aren't looking at an object that is almost 3,500 kilometres across, and you are looking through an immense amount of atmosphere. When you are looking straight up, you are looking through significantly less atmosphere than you would be if you were looking at something at the horizon.
So then what happened, I took the camera and I zoomed in on the moon. The moon just happened to be in the sky at the same time, so I tilt the camera upward and zoom in on the moon, and I could get better detail on the moon than I could on a tree line that was 2.5 miles away. So I found that to be a little odd.
And I find it odd that you find it odd, for the reasons I've just mentioned.
Another thing, while I got it paused here, that I find to be a little fascinating about the moon actually, is that you can zoom in, get all this detail right here. You see the different shadows and the craters and all that. But then when you back up, you lose the detail, and at this point, it just turns into another light in the sky. So I thought that was pretty cool. Just wanted to point that out.
That's what happens when you're reflecting light from a giant nuclear reactor. The fact that the moon is dimmer when you zoom in is likely the P900's automatic exposure settings.
Okay, so let's move on. But why do we only see one side of the moon? that's what we're gonna explore here real quick. And the answer is tidal locking, according to the globe model.
Again, reality, yes.
And this is a article from phys.org, because, you know, the globe model is all about physics. You know, you got to understand physics if you want to understand the globe model, or how to debunk the globe model, for sure. At least that's what they tell you.
Indeed, that is true. You space deniers seem to forget that every time that you make a video.
So it says just here, what is tidal locking? The moon is tidally locked to the Earth, which means that it always shows one face to our planet. In fact, this is the case for most the large moons in the solar system. What's the process going on to make this happen? And the short answer basically is gravity. But no, that's not it. Here's another explanation for it. Tidal locking is the phenomenon by which a body has the same rotational period as its orbital period around a partner. So, the moon is tidally locked to the Earth because it rotates in exactly the same time as it takes to orbit the Earth.
Yes, that is indeed correct, and yes, it is because of the gravitational relationship between the two bodies.
Now, that's another one of those coincidences in this whole globe model, and we got a whole bunch of them. Like, the sun and the moon just happen to look the same size, and when an eclipse occurs, it just happens to take place where the moon is perfectly aligned in front of the sun, although the sun is 93 million miles away and the moon's only 238,000 miles away, but they just look like they're the same size.
D has clearly never seen an annular eclipse then.
You know, the sun is 400 times larger than the Earth, the moon is 4 times smaller than the Earth, so it just happens to work out that way. It's another one of those strange coincidences, much like this whole the moon is tidally locked to Earth because it rotates in exactly the same time as it takes to orbit the Earth. Okay? So it's perfect motion, perfect distance, perfect speed.
Well, when you've got billions of years to get that way, it's hardly surprising, is it?
Huge coincidence, in my opinion. But okay, the answer to why we only see one side, tidal locking. So that's the first component.
Let's remember here that D is building his case. Will be interesting to see where this goes.
Now, let's briefly about Apollo 11, the moon mission that landed the first man, Neil Armstrong, on the surface of the moon. Him and Buzz and Michael Collins. All right, they traversed the dangers of space, landed on the moon, made it back safe. First time anybody had ever done it on a manned mission. Good stuff. We've all seen the post-trip interviews where they're sitting there talking about how they couldn't see any stars, where they're all looking a little dejected, looking kind of depressed, as if they were forced to lie about something. But anyway.
Oh, you mean the post-flight press conference on September the 16th, right? The one that was a full 54 days after they landed back on Earth. That one, yeah?
The Apollo 11 was the space flight that first landed humans on the moon. Commander Neil Armstrong and lunar module pilot Buzz Aldrin formed the American crew that landed the Apollo lunar module Eagle on July 20th, 1969. Okay, so that's the Apollo missions. Now, this is a quick article from space.com. We're just going to look at the title here. The title of this article is Apollo 11 moon landing site seen in unprecedented detail.
Please don't go where I think you're going to go, D. Save yourself, please.
So, not only did they travel 238,000 miles away from Earth through the vacuum of space, landed on the moon, but we can take pictures. That we now have the technology on Earth to zoom in and show the lunar sites, and we have them mapped out.
Don't! Do you think that he's read that little bit under the photo? Let's check it out. The Lunar Reconnaissance Orbiter camera snapped its best look yet of the Apollo 11 landing site on the moon. Orbiter is your key word there, D. This photo was taken by a satellite that is orbiting the moon, not from Earth. Don't! Is that just ignorance there, or is D being a little bit sneaky? I'd say ignorance, because the background is debunking him as he speaks.
So The Apollo 11 lunar site is seen here. All right, from my angle, it's a little bit on the left. Okay, Apollo 11. That's where they tell us that the Apollo 11 lunar site took place. Okay, so that's tidal locking. We only see this one side, and on this one side is the Apollo 11. Still with me? Good.
Just, D-Marble, just.
All right, now on NASA.gov, I go there, I type in Apollo 11, and we have this picture, Earth rising over the moon's horizon. So I click on images, click on that one, download this straight from NASA.gov. Okay, and this is the Earthrise. This is Apollo 11 Earthrise picture taken from the moon of the Earth on the moon's horizon, right?
No, not entirely right, but I want to see you completely fail, so I'm going to let you continue.
Now, here's where I have a question. If we only see one side of the moon because it's tidally locked to the Earth, and the Apollo 11 pictures are from the location specified by NASA on the front, on the side, facing towards the Earth, then why do the pictures from the Apollo 11 mission show Earth so low on the horizon?
Beautiful, isn't it? I mean, how can you spend that much time setting up a debunk and then fail as miserably and as hard as that? Blimey. Clearly, D-Marble has issues reading segments of text that are underneath photos because this photo was not taken from the surface of the moon. If you actually go onto the NASA website and click on this photo and read the text underneath, it says, Earth rising over the moon's horizon. This view of Earth rising over the moon's horizon was taken from the Apollo 11 spacecraft. The lunar terrain pictured is in the area of Smith Sea on the near side. It was taken by Michael Collins, who was on the Apollo 11 command module, which was orbiting the moon once every 2 hours or so. So, not really that hard to get an Earthrise picture then, is it?
Now here's what I mean. In this little picture here, it's showing that the head of the man on the moon is facing towards the Earth the whole time, right? Okay. Because the face of the moon is locked on Earth, pictures with Earth would have to be taken with the camera at a 90-degree angle, meaning the camera needs to be facing straight up.
You know what? We don't even need to see any more of your video because you have failed to understand something extremely fundamental when it came to your argument. Everything that you set up was for nothing. Congratulations on making the absolute worst moon landings debunk video I have ever seen. Right, what a glorious end to the video that was. I really enjoyed that one. Thank you, D-Marble, for making it so that we could see you fail so gloriously hard. Thanks for watching. If you enjoyed it today, then please do drop a like and subscribe. I'll be thoroughly appreciative. Again, thank you very much for watching. I have been Simon Dan. Have yourselves a great week, and I'll see you all on Friday, where we see just how popular Flat Earth really is. See you then.